As we begin chapter 11, we're going to be talking this chapter about rational expressions and equations, and in this first section, we're going to just talk very simply about how to simplify a radical. And last chapter, we took each of our numbers and we used a calculator, and we found an approximation with a decimal, and we would take the square root of 50 and know that was about 7.1. But in this chapter, what we're going to do is we're going to find the exact value in what's called simplified form. And to do this, what we're going to need to do is we're going to rewrite the square root of 50 first as two radicals times each other. So, my first radical is always going to be a perfect square, and my second radical will be about what's left over. For example, as I look at my numbers over here, and I say, which of these numbers goes in evenly to 50? Well, obviously 25 does. And so, 50 is the square root of 25 times the square root of 2. Now, because we have a perfect square on the front half, we're allowed to take the square root of that. And so my answer, very simply, is 5 square root of 2. Now, as a general rule, we're going to write the perfect square first, which then brings it out front as the multiplier or the scalar. So, let's look at our second one, the square root of 12. Once again, we're going to write a perfect square times what's left over. So I say, below 12, does 9 go into it? No. Does 4 go into it? Yes. So 4 times 3 is 12. So the square root of 4 times the square root of 3 is the square root of 12. From there, we say, well, very simply, the square root of 4 is 2. So my answer is 2 square roots of 3. You might also say 2 root 3 as a possible answer. Let's look at our next one, the square root of 20. A perfect square times what is 20? Well, 4 times 5 is 20. And so my answer is 2 root 5. Or 2 radical 5, or 2 square root of 5. Any one of those answers would be acceptable. Let's look at our bottom couple examples. The square root of 27. Once again, we're going to have a perfect square times what's left over. I go to 27 on my list, which is in between 25 and 36, and I go down and I say which of these numbers goes into 27? 9 does. So 9 times 3 is 27. So the square root of 9 is 3, and so I have 3 root 3 as my answer. On a larger scale, the square root of 500, we still take a perfect square times what's left over, but now it's 100 times 5. You might have thought 25 goes into it, or 4, but we always want to choose the largest number first. So my answer in this case will be 10 root 5. On our next one, we have the square root of 8. Well, the largest thing that goes into the square root of 8 is 4. So 4 times 2 is 8, so my answer is 2 root 2. So this is just some simplifying radicals just with numbers. In our next section, we're going to talk about simplifying radicals that had variables. And as we think about our variables, we need to think about the fact that these numbers over here on the right, x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 12th, and so on, all of these are perfect squares as well. So, we're going to be looking at two different possibilities. But once again, we're going to take a perfect square times what's left over. Well, the largest thing that goes into 24 is 4, and what's left over is 6. N to the 8th is a perfect square, and so that's going to go in the front. Any even number is a perfect square when it comes to an exponent. So my answer is 2 n to the 4th times root 6. The exponent we divide by half. So we divide the 8 by 2 and get 4. Let's look at our second one. The square root of 75. Well, that's 25 x to the 4th times 3x. You may say to yourself, why is the x at the back? Well, an even exponent, we take the largest even exponent under 5, and that's x to the 4th. So my answer is 5x squared times the square root of 3x. We cut the exponent in half. Here we cut the exponent in half as well. So that's my answer here. This last one is an example of what happens when you have a number out front to start with. You just carry it along. So 16x squared is my perfect square that goes into 32x squared, and there's just a 2 left over. Now on the outside, I'm going to have a second step in the middle. I'm going to have that 3 times 4x times the square root of 2. The square root of 16 was 4. The square root of x squared is just x. I cut the exponent in half. Now I multiply the 3 times the 4 and get 12x root 2. This finishes up part 1 of section A, section 1A.